Till our previous video, we have seen what is data engineering versus data science. We have seen various sources, what data engineers do in their day-to-day activity, how that is different from data science, and who are the analytical ML, AI, and Gen AI developers, and how data engineering becomes the upstream of data science. We also discuss about the skills which are required to be a data engineer that are non-negotiable and why. And we also discuss about the two type of data engineering, that is SQL focused and big data. In big data, we also learn why it is being translated as a data engineering nowadays and what all coding and what all framework we need to learn as a data engineer. In continuation to that, next video.
Welcome. From today onward, we are going to discuss about the Apache Spark, and then we will understand its architecture and lot more other things. So this is a primary introduction for all. Okay. So before jumping into the Apache Spark, I want to understand you the two terminology which we are using now. Okay. First will be the node. We will call it as a node. Okay. Let me zoom it a bit. Node. And when I will say a node, it is referring to a single machine. Okay. Single machine. And the another thing which I wanted to let you know is cluster. Cluster, when I will say cluster, it will be a multiple nodes. Multiple nodes. Okay. So what do I mean by a single machine over here? Okay. If I take any machine, next I'm referring a laptop or a desktop, anything to a machine here. So this is a single machine. Okay. This is a single machine on it. And let's say it is having some configurations, 6 GB of RAM and 512 GB of SSD. Okay, these are my storing unit on it. So when I say cluster, the same thing will come into here, but in different format. Okay, so these three machines over here will create a group of my clusters. Okay, and this will be, I will be calling it as a cluster for me. So this what create a cluster. And again, if I will let's say if I say what are their configurations. So 8 GB RAM of each and 512 MB of GB of SSD for each. Okay, for each. Per. So why I wanted you to know about this before we get started into it, because there are two approaches in our world. Okay, based on these two, there are two approaches. Okay, so one is monolithic and one is distributed. So what is difference between a monolithic and a distributed kind of a system? So in monolithic, let's say if I am running my machine into 8 GB of RAM, 512 GB of SSD, later on a time when my data is growing in rapid scale, I have to scale it. Okay. And in this laptop or in this desktop, I have a slot and I upgraded it to 16 GB. And that is the maximum capacity for that. I can't grow beyond to 16 GB, let's say 32 GB, 64 GB. I can't do that because my system is not supporting, but my system is supporting a 1 TB of SSD as well. So I upgraded this. Okay. So this can be done in a single machine, and I have done this kind of scaling. Okay. This kind of scaling on a single machine is called vertical scale. Okay. And as I mentioned, I can't go beyond 16 GB because the motherboard of this laptop doesn't allow me to do. So this is a kind of a limit to this machine, right? Now I have to do something about this machine. Either I have to change the motherboard, I have to do something that can accommodate more RAM, more storage into it. Correct? Now let's come to the cluster mode. Okay. If I say a cluster mode over here, so you see there are different what we say desktop present over here. Okay. So different desktops are present. And what I wanted to do is I wanted to increase one more. Okay. So what I will do, I will take this desktop for me and I will say, okay, bring one more desktop. And now it will have 8 GB, same configurations, 8 GB, 512 GB of SSD, same configurations as above. Okay. So it has came to this picture. Now, if you see 8 for the 32 GB of RAM is present here. Okay. And 512, 1 TB, 2 TB of hard disk is present here. Okay. SSD is present here. So this is a cluster mode. And Apache Spark work on the cluster mode type of thing. Okay. And this is called distributed. And this kind of scaling, which we have done, we have added a new computer here. This is called horizontal scale. And in this kind of scale, I can give you two kind of things. Okay. Either you can directly come into this node and you will upgrade the RAM to 8 to 16, like how we have done in our normal node. Like here we have upgraded, right? Like either I can come and upgrade the single machine and do that, but that is not that is not optimal thing we do, because adding a new machine makes it big better for us. Reason why, when you want to upgrade a new RAM, you will upgrade 16 to it. Definitely cost will be there, but at that time when you have decided this, there will be a lot of cash flow with you, so that you can upgrade your all the clusters. Okay. And this kind of things are happening in hybrid cloud. So Apache Spark as a whole work on a cluster mode. Okay, not on a single machine. So this is a horizontal scaling. This is a vertical scaling. Definitely, the mixture of both monolithic and distributed have been used in data engineering to provide a better availability. Okay. So this is the terminology which I wanted to know you. Okay. Now coming to it. So definitely, before Spark, there will be something, right? So what was before Apache Spark? Apache Spark. There should be something, right? So in early days, like how I have told you in the introductory video, there was a MapReduce. Okay. So what was the use of map here? Map used to distribute the data to different machines. If I said map work was to distribute this data in different machines. Let me copy this machine and I will paste it here and paste. So let's say I have these three machines over here. Okay. And actually these are four. Map work was to distribute this data to different machines. As simple as that. Okay. It will distribute the data into each and every machine. So this was the use of map. And what was the use of reduce? Reduce was to read the data from these machines. So reduce is going to read the data. Okay. Reduce is going to read data. While performing this complete operation, right, you have to go into the intermediate disk. You can't just keep it into somewhere and then you can read it. So this process of reading the data from the disk and coming back to the data, what make this process of MapReduce a bit slower. Okay. So this problem usually arises when you have a lot of more data in your enterprise systems. So what they've created is the solution was Apache Spark. The solution was Apache Spark. What they have done is they say, okay, we will compute everything in RAM. Okay. Since I have given you the example, right? We have 32 GB of RAM. And let's suppose you have to process 10 GB of data. Okay. 10 GB of data. So it will directly fit into your memory. Even leave 10 GB of data. If you are processing around 1 TB of data, 32 GB of RAM is capable of performing it. So around 32 into 64. So around 1 TB, 1024 divided by 8. Okay. And it will give you the amount of time it will use to calculate your process your database. So they tell like, okay, we will do everything in our RAM. Okay, we are not going to use any kind of intermediate disk in between. So intermediate disk concept was reduced from here, and they directly use this RAM in between. Okay, so they used to write each and every data over here first to the disk, then read it. So this approach was okay. This was okay when your data is not like gradually growing. But if your data is growing very sharply and it is you can't just use that intermediate disk solution. You have to think of something. So that's why the RAM was introduced. Okay, the Apache Spark, RAM was not introduced. Apache Spark was introduced. So Apache Spark came into the picture and it said, I will process the data into the complete into the computation of random access memory. Okay. So when this was launched, it came with certain features as well. So first of all, in memory compute. Okay. Then they provided that we will do a lazy evaluation. What is lazy evaluation? I will be telling you. People who are from Java background, they might be knowing that what is lazy evaluation, but this is we will be talking about this later in our videos. Okay, then the fault tolerance of the system, then partitioning. Partitioning was a like revolution in the sense of Apache Spark. Okay, not in a complete manner, because partitioning was there from the start, but well, these people started giving us the features of Apache Spark. They came with this major form. Okay, and what was the important thing upon this? So whatever you see over here, right? Whatever API you see, they provided us the API to work over it. Okay, so whatever API they give, that can be used for streaming and processing, even the batch process. So you don't have to create your own APIs. They have given you a multiple APIs, and we can directly use those API for both streaming and processing, batch processing, multiple things. Same API can use. Minor tweaks will be there. Okay. So this was the whole fundamental why Apache Spark was introduced, why MapReduce is not used in today's world, because we need faster, faster retrieval, faster performance of our data. While coming to this, Apache Spark is like right now 100 times, up to 100 times, I can say, it will give you a better performance than MapReduce. So that is the reason why Apache Spark is so in demand nowadays, because data is growing gradually in humongous amount of view. Like you might have also created various data, right, over YouTube or if you write any blog. So people are generating a lot of data. So for all of that, Apache Spark was introduced, RAM computation was used, and this was the complete picture about this. Okay. So in next video, we are going to discuss about the Spark architecture, how Spark work internally, so that we can start our basic thing over there one by one over the topics. So Apache Spark architecture is something which is asked in interview as well. So I will be giving a detail over one video. It will give you a real world example so that you can understand it better. Okay. But I need your support in this. If you are liking the video, please hit the subscribe button, like the video, drop your comment. If you don't understand anything in the video, let me know. I will improve it, or I can explain you over the comment over one to one. Okay. So it will be helpful for me as well. Okay. Meet you in the next lecture.